Hello, sixth period. Unfortunately, when we have these 2-hour delays, I have a conflict with sixth period 7 honors math and my 8th grade algebra. And unfortunately, I had to choose them this time because they are starting a brand new unit and there's no prior knowledge for me to have them work on the new unit. So I had to choose them this time. Last time this happened, I taught your class and they had to work independently. So I apologize, but we're going to use technology and keep moving forward. Here we're going to complete our guided notes on rationals in real life. So we see rational numbers. Frequently in real life. Brainstorm words that indicate a positive or negative number. So I'll give you an example and then you can fill in some of these yourself. Things like credit is a positive, like think even decimals, think fractions, and you can think whole numbers. So if you can have a credit on your bill, you can also have a debt. If you can have a profit, you can have a loss. You can go to the bank and you can make a deposit. And if you can make a deposit, you can make a withdrawal. So those are some ideas, but there's plenty more. Think positive and negatives. I'll let you add a couple more on your own. Here it says, think through the situation. So we're going to solve these word problems or situations. Then follow the rules for adding and subtracting rational numbers. Draw a number line or model to help. So models and number lines, anything that's visual tends to be very helpful when thinking through these problems. So now the first thing we're going to do is look at this problem and think about what we know. What does the problem tell us, the facts that we know? So during a drought, the local lake was 2¼ feet below normal levels. And then 2 weeks later, the water level had dropped an additional 1 3/8 feet. How far below normal level was the water after 2 weeks? So let's just, before we start thinking about exactly what we're going to do math-wise, let's think about what we know. That the first thing it did was drop 2¼ feet. And then the next thing we know is it dropped again 1 3/8. So those are the two basic pieces of information we have. So what is it that I need to know? I want to know how far did the water level change. So this is asking us for a total. Okay? Now you're going to plan and work. So we have, is it just because it dropped twice, does that mean it's a subtraction problem? No. I mean, in a sense that we're subtracting it from 0, and then we're subtracting it from 0 again, but we represent that with negative numbers. So we're going to take this negative 2¼ feet, because we know it dropped. It doesn't say negative in the problem, does it? But because it's going below 0, we're going to go under It's dropping below 0, so we're using a negative 2¼ feet. It was a net loss. And then 2 weeks later, the water did another net loss. So are we subtracting 1 3/8 from 2¼ No, because we know that this was a loss plus another loss, and we want to know what the total was. Okay, so here we would want to change. Big times bottom is 8 plus top, and that's negative, plus big times bottom is 8 plus top. Oops, I almost did 24. Isn't that funny? 8 plus 3 is 11. We're just going to make that a fancy 1. Okay, so now we see that they're the same signs, add and keep, but can I add them yet? No, I can't, because I have to make them common denominators. So I know that 8's a factor of 8 and 4 is a factor of 8. So I'm going to go ahead and use 8. Pardon me, I'm starting to get sick. Oh boy, oh boy. So if I have to multiply 4 times 2 to get 8, then I have to multiply 9 times 2 to get 18. And I can keep the negative 11. Now I have same denominators. And I have an adding problem. So we use my adding rules. Same signs, add and keep. 18 plus 11 is 29. 8. And add and keep the sign. So it's negative 29/8. So now am I done? Is that my final answer? I mean, we've done a lot of work. We had to set up the problem. We determined that it was an addition problem, but that we needed similar denominators. And then we changed our denominators over, and we found our lowest common denominator, made them both the same denominator. Now we've actually done the adding, used our adding rules, a lot of steps. So are we done? We need to simplify. We need to make this from an improper fraction to a mixed number. And I will tell you, sometimes, I remember this from when I was in school, the biggest danger is forgetting that negative sign when you're done. Got to keep him going. So how many times does 8 go into 29? Well, 8 goes into 29. If 8 times 4 is 32, so that's too many. 8 times 3 is 24, so we're going to use 3. Don't forget your negative. And that leaves me a difference of 5. So 8 times 3 is 24, plus 5 more is 29. And I can't reduce that anymore, so we're done. So my solution is negative 3 and 5/8. Okay, so I would like you to go ahead and work the problems here on this sheet. I don't know where my second page is. Or maybe this was only one page. I don't know. And work on the homework here. And if you don't finish during this short period, then finish for homework this weekend. Okay? Thanks.